Hello everyone, you're welcome to prevent a solution given this nice algebra problem, which is x to power 3 subtract x to power 2. This is equal to 100. What are the values of x? Now solution from here. Now we have x to power 3 subtract x to power 2. This is equal to 100. Now let's take 100 on the left hand side so that we have x to power 3 subtract x to power 2 subtract 100. This is equal to 0. We can express 100 as 125 subtract 25 here, so that now we have x to power 3 subtract x to power 2 subtract. Now here we have 125 subtract 25. This is equal to 0. The next step here, we have x to power 3 subtract x to power 2 subtract 125, which we can express as 5 to power 3. Now, plus 25, which is actually 5 to power 2. This is equal to 0. The next step here, we have x to power 3 and 5 to power 3. So that implies that this is x to power 3. Let's combine this. Subtract 5 to power 3. Now, subtract x to power 2 plus 5 to power 2. This is equal to 0. Now here we have x to power 3, subtract 5 to power 3, subtract. Now we can express this as x to power 2, subtract 5 to power 2. If you say negative times negative 5 to power 2, this is the same thing as plus 5 to power 2. This is equal to 0. So this implies that we have two parts here. The first part is the difference of cubes expressed as a cubed subtract b cubed. And the second part here, this is the difference of two perfect squares expressed as a squared minus b squared. Therefore, we have that a cubed minus b cubed. This is the same thing as a minus b, a squared plus ab plus b squared. And therefore, x to power 3 subtract 5 to power 3. This is the same thing as x minus 5, x squared plus 5x plus 5 squared, which is equal to 25. Let's call this equation 1. And then we have the second part, which is a squared minus b squared. Now we have the second part here, which is a squared minus b squared, which we can express as a plus b, a minus b. So in this case, we have x squared minus 5 squared. This is the same thing as x plus 5, x minus 5. Let's call this equation 2. Now let's combine equation 1 and 2, so that now we have x subtract 5. We have x squared plus 5x plus 25. Now subtract. Now here we have x plus 5. We have x minus 5. This is equal to 0. So from what we have here, x minus 5 is common here. So let's factor out x minus 5. So that now here we have x to power 2 plus 5x plus 25. Then subtract x. This is x plus 5. Close the bracket. This is equal to 0. Now let's proceed. Now here we have two parts here. The first part is x minus 5. This is equal to 0. And the second part here, we have x to power 2 plus 5x plus 25, subtract, now this is subtract x, subtract 5, this is equal to 0. Now here that implies that x1 here, this is equal to 5. Let's solve for the other values in this, the next part here, which is x squared plus, now we have 5x minus x, this is 4x, then plus, this is 25 minus 5, which is equal to 20, this is equal to 0. Now this is a quadratic equation of the form ax squared plus bx plus c, this is equal to 0. And this implies that a from this quadratic equation is equal to 1, b is equal to 4, and c is equal to 20. So from here, let's assess the nature of this quadratic equation by determining the discriminant value, which is b squared minus 4ac. So now substituting the value of b here, we have 4 squared minus 4 times a, which is 1, times c, which is equal to 20. So this implies that 4 squared, this is equal to 16, subtract 4 times 20, and this is equal to 80. So 16 minus 80, this is equal to negative 64, which is less than 0. And this implies that we have two complex roots. We have two complex roots in this case. And so for this two complex root here, that is x2 and x3, we apply the quadratic formula. That is minus b plus or minus the square root of b squared minus 4ac, all this divided by 2 times a. So let's substitute the values of a, b, and c. So in this case, we have minus 4 plus or minus the square root of b squared minus 4ac, which is the discriminant value here, which is minus 64. So we have negative 64 here, divided by 2 times 1. So then here we'll have negative 4 plus or minus. Now we can be able to express negative 64 basically as 64 multiplied by negative 1. All this divided by 2. So here we have negative 4 plus or minus the square root of 64, this is 8. The square root of negative 1, this is I, divided by 2. So here, 4 is, we can factor out 2 here, so that here we'll have negative 2 plus or minus 4i divided by 2. So let's simplify here, so that now we have x2, x3 equal to negative 2 plus or minus 4i. So in this case, x2 is equal to negative 2 plus 4i, and x3 is equal to negative 2 minus 4i. Now these are the two complex solutions here. These are the two complex solutions that we have. And we have only one leaf solution here. We have only one leaf solution, which is x1, which essentially is equal to 5. So this is the only leaf solution we have. So let's verify here. Let's verify. Now, if you recall here, we had that x to the power 3, subtract x to the power 2, this should give us a value of 100. So x here is 5, so this is 5 to the power 3, subtract 5 to the power 2, this should give us a value of 100. 5 to the power 3 here is 125. Subtract 5 to the power 2 here, which is 25. This is equal to 100. So here we have 100. This is equal to 100. And that implies that the left-hand side is equal to the right-hand side. And that implies that we have three solutions in this problem, algebra problem. That is x2 and x3, which are the two complex solutions, and x1, which is a real solution. So thank you for watching. Kindly follow the steps, like this video, and subscribe. Hit that subscription button so that you can get notified whenever I upload new videos. Thank you for watching, guys. Bye bye.